Hi, everyone. How are you? My name is Joy, and I am the Assistant Director for Strategic Partnerships at the Data Science Institute here at Columbia. So today we have the iCube seminar, which stands for Institute, Industry, and Innovation. We invite our affiliates to come on campus to talk about their experiences or a recent project or case study that they've worked on. So for this educational seminar, we just ask and encourage you to ask questions at the end of the session. So today we have Subhabrata Das and Maryam Kabiri from JPMorgan Chase. They are Vice President and Lead Data Scientists at the company. So thank you so much for joining us.
Okay, thank you so much, Joy, for introducing us, and thanks again for inviting us. So I'm being Columbia graduate. It feels special always to come back to the campus and kind of engage in this kind of community engagement conversations. So this particular topic is like we are talking about, since we didn't do our PhDs. Both of us, both me and Maryam, we are colleagues in JPMorgan Chase, and we didn't do our PhDs in computer science department, but we have kind of did PhDs in similar kind of areas, and we then transitioned further into data science and computer science domains. So the first goal is that what we did. So we are not giving much information about what we do at JPMorgan Chase right now, but we will at least cover similar topics here. So first we will talk about what is our journey at Columbia, and University of Colorado Boulder for Maryam, and then what are the similar kind of case studies that we have worked on that are relevant to finance and JPMorgan Chase. So, first my goals, my PhD journey started with kind of exploring, chemical reagents and how structure and properties of certain surfactants, which are the surface active agents which are present when you use detergents. We wanted to kind of study the foam physics there. So there was some professor in Data Science Institute there with whom we were collaborating at that point of time. So I was from environmental engineering department and focusing in soft material physics. And we had that interesting idea that how we can study at the interface of energy, water, how we can study at the nexus of harnessing renewable energy and also conserving water. So wanted to study the role of various chemicals, reagents there. So this is also the structure of a protein. So how the protein conformational dynamics I was studying. So the reason for having said that is that these were some of the topics which involves a lot of multi-scale modeling techniques and how machine learning can be used to kind of explain a lot of the physical understanding or physics of this protein conformation or surfactant folding, surfactant interaction at the air-liquid interface. And you have seen probably even the Nobel Prize in Physics this year has been awarded to somebody in machine learning and deep learning because of the foundational work in adversarial neural network. So, so that was my PhD goal, and some of the studies that I did that time and continuing to do in my spare time, I would say, is to study the interfacial dynamics of particles straddling air-water interfaces and how we can study hydrodynamic interactions. So maybe like people who are familiar with fluid dynamics and have developed machine learning based models or physics-informed multi-scale models to study physics, they would be familiar with this topic. So understanding Brownian motion of particles at air-water interface, multiple particles. So these were some of the papers that I had published a few years ago on studying hydrodynamic interaction of particles at the air-water interface. So these papers you can read online. There are around four papers that you can study. And then further, I wanted to I did a little more of image analysis and also develop multi-scale models to study the hydrodynamics of particles, multiple particles at air-water interfaces, that when you have particles being recovered using a flotation process in a mining operation, then how these particles get entrapped by liquid droplets, and then they float to the top, or bubbles, and then they float to the top. Because when they get attached to the bubbles, they become buoyant and they go to the top, and the mineral is being recovered. So I was studying. So these are just at the various time steps, or the images of droplets in here, droplets or bubbles here in liquid, and there when at 100,000 time step. LB is the lattice-Boltzmann model that time I had developed, which is based on fictitious particles which are moving in certain directions in space. And so this is with spherical, this is without any particles here, how the droplets are coalescing at the top with time and forming bigger droplets. And when we have ellipsoidal particles here, the ellipsoidal particles are getting entrapped by the droplets here and going to the top. So more of like understanding of emulsions and froth. But this all are physics-informed multi-scale modeling, I would say. And that is where the reason being. And then there were some projects that I had done on fabricating a bioperovskite solar cell, how bacteriorhodopsin protein, when layered on a titanium dioxide surface, when comes in contact with or brought in contact with a perovskite interface, how electricity can be generated, and we can simulate artificial photosynthesis. And that way, the diagram in the left, as you can see, is more of a band gap diagram, which shows the bacteriorhodopsin protein, titanium dioxide, and the perovskite material, and so on. And the diagram in the right side is more of a ellipsometry, what is called as spectroscopic ellipsometry, that was used to study these bio-nano interfaces. So this is also kind of some of the published paper, and I'm writing a book also relevant to that. So now that you have seen some of my PhD journey, now I would like to explain some of the work that was done a little bit post-PhD, but more applied machine learning. And this one work that we recently published in Nature Scientific Reports is that how we can use tomato machine learning to understand tomato leaf classification in sustainable agricultural techniques. A lot of time is invested in identifying the bad crop from the good crop. So people who are in sustainable program, they will know that better. So a lot of machine learning is being used to kind of study the physicochemical effects, as well as the understanding the classification of bad leaf versus good leaf in tomatoes or any other agricultural crops. So this gives more precise, more of digitization of the agricultural technique. So in the left side, we have the MCC score. This is one of the more recent metric that is being used in our hybrid Bayesian optimized deep learning model that we developed here. And here we showed that the CNN stacking method gave the best accuracy compared to the random forest or KNN or XGBoost based techniques. And in the right side, we just show the confusion matrix, where we show what is the score of identifying a bacterial spot or a lead blight or a leaf mold or a target spot, and so on. So various case studies we did, and there were two kind of data sets was being used. That was the plant village data set, and more of a realistic data set, that is the bone of the data from the NASA GISs. So that being said, this there's another work that we have submitted also. That is also with in collaboration with a professor in the environmental engineering and computer science department, where we have used stacked LSTM architecture to kind of predict the number of power outages for the state of Michigan. So here, as you see, that the LSTM architecture is a very simple architecture, but we had a dropout layer of around 0.2, and then we do some of the atom optimization, and in the output layer we have one node, and then what we did is we also combined with PCA to kind of denoise a lot of the data. And because this is a time series based data, because we wanted to predict the part of outages in state of Michigan based on weather data, so that was more of I would say a time series based model. So that is why LSTM was being used. So this is like, as you see, that we transition from more of soft material physics into more of machine learning based research in applying to various problems, both industry, both more of outside finance, and obviously machine learning comes into finance more. So in one of my past jobs at Ally Bank, what we were working on was a RASA based architecture. So we were using conversational AI to kind of identify that what are the positive and negative sentiments of the customers, and how we can answer a lot of the customer questions in a much more efficient way. And that is where we came up with the, this is just a RASA architecture. You can search online what is the RASA software for chatbot. And it involves a lot of the natural language understanding the intent and the entity portions, and what would be the right actions that we can take so as to make the bot answer questions in the most logical fashion. So this is also kind of a snapshot of the intents and the entities, and what are the slots and responses, which are part of any conversation that any conversational agent is involved with. So we had in the chatbot, we had something called an intent, what the user is implying, and the entities are the pieces of data that can be extracted from a user message. And this message would have two pieces of information. This example I'm giving just is the name and the email, and this can be extracted as entities. So as you see that a lot more work has obviously happened over the last few years further in the conversational AI space, especially after the invent of LLM. So now I will let Maryam speak a little bit about her journey, and then we can go for more interactive discussion.
Hello. Can you hear me? Okay. So my journey to be a data scientist started from summer 2008 from University of California, Berkeley. So I got admission from I got admission from University of Colorado Boulder as a PhD for economics. And then after finishing all the courses and preliminary exams, so I had this opportunity to go to the University of California at Berkeley, and then participate in two projects with one of the professors. It was related to the energy efficiency and impact of energy efficiency in the innovation about the job creation in California, specifically in California. Mostly they were focusing on the consumption of the appliances and anything related to the residential building or residential sector. And as you see that, they saw that, during over the, past 20 years, the consumption with the energy efficient appliances, it's decreasing the consumption of the electricity or gas in the household, and also, decreasing, the carbon emissions. So by that time, I didn't have any idea that, what I'm going to do for my thesis. Then I came back to Boulder, Colorado, and I thought that, I can focus on the building, efficient building, rather than, appliances and other, efficient, project that, they already done. So I started focus on the impact of the most recent intense building energy efficiency policies on the consumption of the energy for U.S. residential since 2003. The one that, the time that, these policies has been impacted. So we know that in US, even before 1970s, the oil and gas prices crisis, so we had type of the energy efficiency policies. But after 1970s, so they went very regressive about these, policies, and each decade, we had different type of the energy efficiency policies for the buildings, appliances, and everything. So I picked up the most recent ones. So, and then I did lots of time series analysis, and then different type of the statistical models to see the impact of the energy efficiency policies on the consumption of the energy. So I had a comparison between the states that they did have the policies and the states they didn't have the policies. And I find out that the most regressive policies that time, which was 2012, for example, EICC, so they decreased the consumption of the energy on those states by 12%, which was a good finding. So by working on these papers, I got interested on working on the data and exploring the data and do these kind of the analytics. So after graduation, I had the opportunity to go and work on the theoretical paper and empirical paper. So then I chose working on the empirical, aspect of all the, these policies, because I really like working with the data and then get, some insights from the data. So for the economics that time, so we didn't have the Python codes classes or R or anything. So these days I know that all of the department, they are teaching Python and R and everything. That time we had some statistical packages. So then I saw that I'm kind of lacking on that part, so I have to increase my knowledge about the coding part as well, and then integrate it with my background from the PhD in economics and become a data scientist. I took some courses in Coursera. I'm sure you are familiar with the Coursera from Johns Hopkins University. So I got familiar with the coding, with the Python, with the R, and I worked on the several projects. And then I understand, how I can use the coding, to implement all the statistical models that which I learned during the PhD and my thesis, onto the real life. So then after a couple of, applying for the position, I got a position in the Verizon as a data scientist and machine learning engineer. So now the real life has started. So when you're working with the capstone, or with the, I can say that with the Johns Hopkins, data. The data are clean. You don't have any problem. So they give you the clean data. You feed into the model. Okay, good. So I got the recall or accuracy of 90%, 95%. Oh, I did a great job. But in reality, it's not the same at all. So you go to the company, Verizon or any company you go, you don't have this clean data. You have to understand your data. So you get the data, and for example, 1 million records of the data from the clients, and you have 950,000 for the label. So suppose that you want to predict something, right? So you have 50,000 or 5,000 label of the 1 and 995 label of the 0. So how you are going to predict those ones? So the ratio, it's 1%, even less than 1%. You have to see that, how you can tackle these problems in real world. So to be honest, real world is completely different than, the things that, you see on some of, the courses. It was a very good experience for me. So I understood that, when you have these kind of, for example, imbalanced data, you have to balance your data. You have to come up with some idea that, you can increase your performance of the model. So even though, you are sampling your model, oversampling or, undersampling your data, and you are getting a good accuracy. But when you put these into the production, again, you don't get that much good accuracy or precision or recall that you were expecting from your data. You have to tackle with all these problems in the real data. So couple of projects which I worked with the real data in Verizon. So one of them was, expediting closing, the messaging tickets. So when in the messaging ticket, in messaging part section, when they are getting the tickets, people, they could, close the tickets very easily and, very fast. So maybe in less than an hour, they can close the tickets if there is some problem happens. But sometimes it takes time, maybe one day, 2 days, or a couple of days, it takes, to close the tickets. And the clients are getting, just exhausted, and they are asking what did happen, and sometimes they were escalating these to the CEO as well. So if you search, you can find Hans Winsberg, the CEO of the Verizon, phone number, so they can call directly to the clients, to the CEO, right? So we have to find a way that to solve this problem. So try to close the tickets as fast as we can. So we had, some closed ticket, we have some open ticket, and we did some NLP based on the conversation they had with the, ticketing system center, and then use some K-means clustering, to cluster the clients based on, their need. So it was so complicated. I'm just giving you a, just a brief or a general, overview about the problem that, we solved there. The other one, it was, step-up prediction model. So we had clients that, I was working with the wireless team. So we had clients that, they had unlimited data plan. And some clients, they don't have unlimited. So they have a limited data plan, and if they overusage, they had to pay, some extra money because of that overusage they had it. So by looking at the data, we saw that, about more than 50% of these clients, which they don't have unlimited data, eventually, they step up, to the limited plan. And it was good for the company because unlimited, they are paying more, right? Even though they are paying more, they have an unlimited, plan. So our, goal was to encourage the clients that they didn't have unlimited plan, to step up and go, upgrade their, plans from limited to the unlimited. This one also, it was kind of the imbalanced data, so I had to come up, to oversample or undersample the data, and then try, predict that which client is going to step up, in the future months. And then we plan, then, I moved to another team that time, but, they were planning to create a push notification for the clients and say that, okay, so client A. So for the last couple of months, you had a limited data plan, but each month, you paid, extra $5 or $10 or $20 or sometimes $50 for extra usage. So then why you don't, step up to the unlimited plan, avoid these, extra costs, and then you have unlimited data. You shouldn't worry about, the usage of your data. And then the call center prediction, and there were a couple of projects which I was involved in. It was very interesting. Another thing that we have to be careful about, when we are working on the real data, we have to connect with the business stakeholder. So see that what they are looking for. Sometimes they are looking for the higher recall, sometimes for higher precision. They are looking for the lower false positive or lower false negative. So this doesn't happen unless you connect with the business team and see that, what's their need, what they are looking for. Are they looking for, to decrease for us, to highlight, the most, the false positive customers or false negative customers? I'm sure most of you are familiar with these topics. And about the last year of me at the JPM, at Verizon, I had the opportunity, to be as a business intelligence manager. So this was a good opportunity for me. So I told you at the beginning, so we have to be familiar with the data. So in this position, I was able, to connect with the business, team, and then find out what's going on the data before running any algorithm, any models. You have to see that, what's the data. And then what you can do with this data. So if you don't get a correct, accurate data, it's going to be garbage in, garbage out, right? You have to understand the data. To my knowledge, so the data is very important. You have to understand your data and the business goal, and then start to do your, machine learning and, all, other stuff that we do. I was able to expose to different, BI tools. And it was very fast speed, environment. So when you are in a big company like Verizon or JPMC, so the technology is changing very fast. You have to adapt yourself to those technology. Otherwise, you will be behind. So for some of the, reports, we were giving, to the CEOs or, the, stakeholders, we were using some, old-fashioned methods. Then, they introduce us, the new BI tools such as ThoughtSpot or ClickSense. We have to adopt, ourselves very quickly. Otherwise, then other teams, they will get the idea and, they will be on the board. So you will be wiped out. So I come up with some ideas using, R and Python code in, integrating with our, dashboards, to generate, more robust, reports, especially for the 5G and iconic pre-order for the devices, iPhone and Samsung. That when they have a new release for the devices, so these companies, Verizon and other companies, they get the pre-order from the clients, and then you can go and buy your devices as fast as you can, or you're on the line, but you can pre-order. And it is very critical for the companies such as Verizon that, shows that how many pre-order do we have, so, and they compare it with the, previous, iconic launch, and then, see that, what's happening in AT&T and, other, rival, companies. So we were able to get these data on time and, give a good, report, which Hans, our CEO, it was looking at these, reports daily. They were told us, he's specifically looking for these. So, and then based on all these background which I have based on the machine learning or BI tools, I'm using all these experiences right now in JPMC. As Subhabrata said, we are not clear to talk about the current project in JPMC, but all of them, even business manager, SQLing the data, getting the data, connecting the data to each other, it's very useful right now for me, in JPMC. I can use all of these experiences in my career right now. That's it.